Hello everyone, this is going to be a tutorial on Lambda functions. This tutorial assumes you're already familiar with functors, and if you're not, I have a tutorial on that you can check on my YouTube channel. This is going to be a live demo, by which I mean I'm going to do all the coding as we go along, as I find that it's very instructive to see the code kind of being built from scratch. And as usual, I try and aim for two things. The first is I try to be as intuitive as possible. I do that by taking concepts that you're already familiar with and then just building upon those. And I like to explain the motivating factors, which are the reasons why we want to use a feature and not just how. So if you're already familiar with functors, then Lambda functions should actually not be too tricky for you, as Lambda functions are just a form of syntactic sugar on a functor. So we'll start with a class dog, and a dog will have two member variables, an age and a weight. And we'll have a dog constructor that takes an age and a weight. And we're going to have a default way of sorting these dogs, which is going to be according to their age. So then we can have a vector. We're going to want to use some algorithms, and we'll want iterator, and we'll use the standard namespace for convenience. So we'll have a vector of dogs, let's make a few of these. And what's the last one I'm missing? 2, 3, 4, 5, 5, and 30. Okay. So we have a vector of some dogs, and we can sort our dogs. And this will use this less than operator and sort them according to age. So when we talk about functors, one of the things that we use functors for is we can have them as different predicates for sort. So we can have this sort dogs by weight functor. And this one will take two dogs that it wants to compare. And this time compares them by weight rather than by age. So we can sort dogs in one way, or we can sort dogs in another way. So that's one of the uses we have for functors. So what we don't like about this is that it takes a lot of extra writing to be able to sort these dogs in another way. So Lambda functions are just syntactic sugar for functors. So syntactic sugar usually exists to make something easier to write. So for example, when you look at this less than operator, you can then write dog d1 will be, say, 110, and you have this dog d2, which is 220, and you can write d1 less than d2. And this d1 less than d2 is actually syntactic sugar for this exact same thing. Right, so basically you never see people use the operators in this form. But if you look at the function declaration, you'll see that's the exact declaration of it, right? So the name of the function is operator less than, and it takes a dog as an argument, and it returns a bool. So you can in fact use your operators written out fully like this, but we don't generally do that because it's much more convenient to use this syntactic sugar. So in the same way, our motivation for lambda functions, in part at least, is to have a convenient syntax for functors. So we can do this exact same thing we did here using a lambda function. And I'll explain the syntax in a moment. Let's create 2 dogs. So the first thing that I want you to remark is that this functor which we made to compare dogs by weight looks remarkably similar to this lambda function. Right? So we'll start with the parts that look exactly the same. So first of all, we have this argument list, which is precisely the same, because we're going to use this lambda function in exactly the same way, where we're going to take 2 dogs and we're going to compare them by weight, same as up here. So this lambda function, which is syntactic sugar for this functor, actually desugars, right? So syntactic sugar is making something easier and more convenient to write. And if you say the desugaring, it's kind of the opposite process. So this lambda function desugars into something that looks extremely similar to the sort dogs by weight functor. And that's the basic idea of a lambda function. And there's just a few things that you need to be aware of that make things different. So let's consider another example, not with sort, but with find. So we'll want to be able to find dogs according to age. So if I have an age, I'd like to know if there's a dog that matches that age. So we're also going to have a find dog by weight functor, because we'd like to do the same thing, but this time we're going to do it based on weight. And this is actually going to take its argument slightly differently. Okay. So what that allows us to do is now we can use this find, and we can find a dog based on a certain age by default. So let's say we do it that way. But maybe we want to do it by weight instead. No, sorry, we're trying to find if. I'm trying to find it by weight. Find dog by weight, and we're looking for a dog with weight 20. And then we'd like to do the same thing, but with a lambda function this time. So here, the weight that we're trying to find, we use as an argument as the constructor of this functor. So do the same thing for a lambda function. It looks something like this. And again, I'll explain this in just a moment. Okay, so again, I want you to remark how the lambda function that takes a dog and compares the dog's weight to this weight looks very similar to this functor that we made here, right? Where this functor takes a weight as an argument to its constructor, and it stores that as a member variable, part of the functor state, and it uses that when it wants to compare it to a dog. So just as this is kind of seen as the this is the constructor for this struct, for this functor, this is called the capture list of a lambda. And you can think of this as the constructor arguments for your lambda function. So you also could have written the lambda function like this. And you're saying this lambda has a member variable called weight, which I am going to initialize to 20. In the same way that this 20 is used to initialize the member variable weight. There's a few things that are slightly different about this capture list though. So let's say, for example, in this find dogs by weight functor, I didn't want a weight, I wanted a weight reference. So I would have this integer by reference, and that's how the syntax would change. In a lambda function, the way that you do a similar thing is you put just this ampersand in front, and here you can't have a reference to this literal, so here you would need to say there's this weight, and I'll have a reference to the weight. And here it's allowed to have the same name. This is called the Lambda's initializer, or capture initialization list. And this says this lambda is going to have a member variable called weight. Again, you could choose to write this as, let's say, m_weight, as we did in the functor above, and say it's going to be initialized with this weight, and here we say it's by reference. But it could also have the same name, and there's no problem, because this weight refers to the weight that's in the lambda's scope, right? So this is in the same scope as the lambda. And this weight is a member variable of the lambda we're going to create. And you can capture multiple arguments. Let's say, for example, we wanted to capture some age that we're not going to use for some reason. So let's say we had an age. In this case, this states that I'm going to have two captures, one of which is age, which is going to be captured by value, which is the default when there's nothing in front of it, in the same way that this int is the default. And if we want it to be a reference, we add this ampersand, right? So this age is the default, it's by value, and this weight is by reference because it's an ampersand. You could also have done just like that, which says I'm going to capture weight by reference, and I'm going to make a member variable in this lambda, which is an int reference to weight. You can also specify a default capture mode. So you can put just this ampersand. And this says every variable that's in my scope that is used inside of this lambda function will be captured by reference. So here, for example, in this lambda function, we are using weight. We are going to capture weight by reference. The other way, if you want it by value, is not nothing. Right, so when you wanted to capture weight by value, you wrote weight and you didn't have any prefix in front of it. If you wanted it by reference, you prefixed it with the reference. If you wanted everything by reference, you did just the reference. But this specifies I have no captures. If you want to capture everything by value, you put this equal sign. And this says I will capture everything I use in this lambda function from my scope by value. Generally, I don't recommend using default captures. There are two dilemmas. The first is that it's not explicit what you're capturing. So if someone else is looking at your code, for example, it might not be immediately evident which variables from the scope are being used inside the lambda function. Makes it a bit less clear. You can think of that a bit as when you have a constructor, you're explicit about what type of arguments your constructor takes. And it makes it clear what your constructor, what your functor needs to be able to work. So in the same way, it's preferable to say this lambda needs weight to function, right? So it needs this 20 value. The other thing is that you may be capturing things that you're not aware of. And the typical example is capturing a this pointer. So I don't have a this pointer in this function because this is not an object. But if you were inside of a member function, if you just wrote equals and you had some sort of member function that was, let's just call it my member function, then it would secretly be capturing the this that you used to call the my member function. And the reason why that is dangerous is because this perhaps is a temporary object which may go out of scope before you use your Lambda function. So generally, if you wanted to capture the this pointer to use with member functions, it's preferable to write this explicitly. And again, in this case, there's no this because I'm not inside a member function. I can do a quick example just to perhaps make it a bit more clear. So let's say we have some function foo, and we have some other function, my member function. And inside foo, we want to make a Lambda function, which is going to use my member function. So here it says you can't use one of the local variables from the scope unless it is in the capture list. And when you look at this, it's not immediately evident what it's complaining about. But what it actually wants to do is it's trying to use the this pointer to call this my member function, right? That's the form of syntactic sugar that's done for you normally, right? When you call my member function here inside the scope of foo, it knows to call it through the this pointer. And again, you can write the same thing with the this being written explicitly. So you could just use default capture here, and now it's content because it's capturing this, but it's not extremely evident. So it's preferable to be explicit with your captures. And you can see now it's also content. So then there's the idea of generic lambdas. So for generic lambdas, we'll have a slightly different example. So we'll get rid of this dog. And we can get rid of these structures. And we're going to make a functor that compares pairs by their first value. So let's compare pair by first value. Or we'll call it order. We'll order them rather than compare them. Order pair by first value. I guess I'll put an S. So here I mean standard pair, which is in utility. So we'll start by showing it as a functor, and then we'll show the equivalent syntax as a Lambda function. So the idea here is that you can have a pair of any two types. Let's say bool char. And I'd like to be able to use this functor to order pairs by their first value, right? So I pretend I had a vector of these pairs, and I had a separate vector of these pairs, and I'd like to use the same functor to be able to order them both. So what you could have is you could have a template functor, right? So this takes any type of object, and we'll have two of them. T const reference left hand side, T const reference right hand side, return left hand side dot first less than right hand side dot first. So in this way, we can compare any types of pairs, right? So if I made a vector of pairs of int doubles, vector 1, and it's make pair, what are we doing? Ints and doubles. So let's just copy that first. 3. Since I had 1 and so integers and doubles, 2, 2, and 3 and 3. And I want to do the same thing, but for bool and character. So it's v2, so we say true, and A, and false, B. And I would like to sort either of them with end, would be preferable. And I want to sort them by the first of their two values in the pair. And I need to specify that this is for a pair of int and double. And I could use the same functor to sort bool char. So we'd like to do the same thing with a lambda function now. And in fact, this should not be here, this should be here. Because, and then I don't need this, even better. Because it's not the whole class that needs this t, it's only this function call operator that needs this t. So what you can do instead, or what you could do similarly using a lambda, is that you use auto to do type deduction. And this is the equivalent form, let's put that semicolon. This is the equivalent form of this functor with the templated function call operator. And in this particular example, these two autos don't necessarily need to be the same type. So for example, if in some other case you needed something like this, let's say, which again works. So for the case of this sorting, this order pairs by first value would initialize t and u to be the same thing, because I'm going to be comparing one pair of int double to another pair of int double. But conceptually, there's nothing stopping you from saying it could be two different types, so long as this less than operator works between those types. And for this lambda, it's the same thing. These two autos are not necessarily the same t as they were before I made this change with the t and u. So there's another interesting way you can do this, another interesting way you can use lambdas as well. So here I showed you how to use lambdas kind of in line with the function. But you can actually also put this first. And it behaves in the same way as a functor, which you would have created first. Kind of wish I had not deleted the other part. Let's put those back so we can compare these. So for example, you could have created, oops, didn't want to delete all that. You could have created this functor first, and then pass it as an argument rather than creating it in line. And again, these two forms are equivalent. So there's another thing that's interesting about lambdas, and it's the fact that this auto here is not mandatory, but I should say it's kind of the most standard. And the reason was, let's say you weren't trying to use auto to deduce the type. What type would you write here? Right? So for this functor, we know what the type is because we declared a structure that represents it. But for this lambda gets turned into a structure, much like this, by the compiler, and it will have a compiler generated name. So we actually don't know what to put here for the type. So what you generally do is you use auto, and it will return the actual type of the lambda. There are a few other ways you can do this. You can use types that have some sort of type erasure, or you can implicitly convert lambdas into function pointers. So another thing you could do is you could say, well, this lambda is actually a type of function that takes, that returns a bool, right? Because it's going to return whether one of them is less than the other. And it takes as arguments, would you be able to use auto with this? Perhaps not. So here you would have to say the explicit types you're using. So in this example, it would be a pair of int double, pair of int double. And then you could say that this lambda is actually something you can wrap in a function wrapper that returns a bool and takes as arguments 2 pairs of int double. And I need to include functional. And then you could still use this in the same way, except in this case you'd be passing this function, which is a wrapper around a function pointer. And this lambda would be implicitly converted to a function pointer to be held inside here and used with this sort as the predicate. But again, generally, most of the time, you want the type of a lambda, you're just going to write auto. And the type, which is created by the compiler, will simply be deduced. And I think that'll cover it. Thanks for watching.